Hello ham radio operators. This is Sandy, KB3EOF from the Palomino Antenna Workshop, and today we're going to look at how to build an antenna that allows radiolocating fox hunting the easy way. The challenge of fox hunting is to build a decent directional antenna and then attenuate the signal enough to pick out the direction. The solution is to go for the third harmonic of the signal. The third harmonic is much quieter than the primary frequency and conveniently falls on the 70 centimeter UHF band. A small, lightweight, three-element Yagi can easily pick out the direction of the fox and can also rotate 90 degrees for cross-polarization to give you additional attenuation when you're closing in for the find. So how to build the perfect three-element Yagi for a fox hunter? Let's start by Googling three-element Yagi calculator and select the first one that comes up. Next, let's choose a fox hunt frequency, say 147.43, and multiply that by 3 to enter the calculator and get our preliminary numbers. So let's try 442.29. All right, this will give you a starting point to input numbers into our old friend MMANA so that we can optimize the antenna to emphasize the front to back ratio. I've already done this, so let me just open up what result I got after putting in the appropriate numbers. There we go. Now you can see the antenna as put in by the calculator, but we do have to make a couple of adjustments. Let's make the height, instead of 1 meter, let's make it 1.5 meters. So, that's about handheld level. And instead of aluminum pipe, let's use copper wire, solid copper wire. And instead of narrow copper wire, let's make it 2 millimeters wide. All right, now we're ready to calculate and just see right off the start what kind of numbers we get. We get an SWR of 2.3 and a front to back gain of 18.2. Okay, that's a decent antenna as it is, but let's see if we can't get a little bit better front to back ratio. So for that, we need to go to our optimization. Now let's go ahead and optimize totally for front to back. And let's do SWR, we'll give us some SWR advantage there. We'll put it right in the middle. And then you want to make it all elements. So let's go ahead and start that optimization. And you see our front to back is jumping higher and higher. There we go, not bad. Let's see what we got now. Oh yeah, much better front to back. The SWR is not great, but recall we're not really trying to broadcast, we're just receiving. So SWR is not quite so important here. Now I did make some additional trade-offs between front to back ratio and SWR to get the numbers to do a little bit better. Plus I took some calipers and carefully measured the wire that I was using. It was a 6-gauge copper wire that I had twisted to make it nice and straight and a little bit thicker, and it came out to be a radius of 2.05 millimeters. So when I calculated that, we got a little bit better SWR, 1.23, and essentially the same front to back ratio. Let's round it to 23. You can see the currents, standard typical Yagi, That's the director. This is the reflector, and that's the driven element. Here are the numbers that I ended up with. So I think this is one that we want to build. Let's go ahead and put this together. These are the tools and materials that you'll need to put this antenna together. You start off with a nice tape measure. Make sure it's metric, because all this is in centimeters and millimeters. Sharpie pen so you can mark where you want to do the cuts. PVC pipe. This is 3/4 inch and at least 48 centimeters long, although you can buy 10 feet of these at a time for about $5 at Home Depot. Get the Schedule 40 thick kind, and I measured the outer diameter. It's 26.8 millimeters using calipers. So if you do have some calipers, take it along with you to double check that size. This pipe cutter makes it easy to cut PVC pipe. It's a ratcheting one. It just cuts it right as smooth as butter. You'll need some solid bare copper wire, 6 gauge, about 5 feet of it, and it goes for about $1.41 right now at Home Depot. You'll also need a vise and a power drill and a file, and I found that will be useful when you want to straighten this copper out. Just put a bend in the end, cut a length of it that you want, clamp that down in a nice tight vise, and then chuck this end into your power drill, and then twist it, and that'll straighten it out straight as an arrow. And you twist it until it just seems to slow down and not want to twist much anymore, and that's when you stop. You'll also need some zip ties to attach your cable to the PVC pipe. RG58 cable. This is about 3 feet that you'll need. This is considerably more. You'll need a crimper to attach your PL259 connector, or you could use a SO239 female, your choice. But you will need a PL259 SMA female connector for your Baofeng, UV5R, or other small UHF HT to find the fox. A soldering iron and some solder will be needed to solder the tip of that. Alright, you'll also need some pin head screws. These are number 8 by 1/2 inch, and they're Phillips sheet metal screws. You'll need a hacksaw to notch the end of your copper wire, and then the drill with a small drill bit to put a hole into the notch there so you can thread the wires through. The hacksaw is good for the notching, and you'll also need a bolt cutter to cut the copper wire. And that this one I got from Harbor Freight. It's about 18 inches long. They're not too expensive. It's the absolute easiest way to cut that copper wire, and then you use this to file down the edge until it's exactly the right length that you want. And last but certainly not least, you'll need access to a 3D printer or somebody who has one, and some PETG filament. The first step in constructing this antenna is to cut the elements of the antenna to length. If you're going to make more than one of these, say for friends that are ham radio operators, to use as spares at a fox hunt event, or to give away as a prize to the fox hunter with the sorriest antenna. It's good to have a template. So cut 3 of the elements as exactly as possible to use as a template. At the end of this video, I'll post a summary of the dimensions for the antenna and the parts. But for now, what we're going to do is we're going to cut the elements that are 29.05 centimeters, 34.2 centimeters, and 16.1 centimeters. Try to get it as close to, say, half a millimeter as possible. As I mentioned, the easiest way to do this is with a template. And then we'll use our vise and a file. Mark, cut, and file to exact length. After you've cut the two shortest lengths, the quarter wave driven elements, put a notch in it. The next step is to put the elements into the 3D printed holders. The reflectors and the directors go in easily. Just slide it in, and then you can get a basic sense of if it's centered or not by balancing it on your finger. There we go.
Good morning. The time is 06:55.
These don't go in quite as easily. Much tighter fit. You may have to actually brace this on the ground and put some pressure on it to get it to pop in. But once it gets in, it's pretty solid. It stays in there pretty well. This cable is labeled RG58A/U. I guess the U stands for UHF. But it doesn't really have to be all of that grade. We're only going to use just enough to connect to your antenna, and then the other end goes into your pocket to connect to a radio. So about an arm's length, something like that. Go ahead and cut your antenna to length. I like to use a non-crushing snip. Next, we'll go ahead and strip the end to attach to our feed point. And it takes about an inch or so, maybe a little bit longer. I give it one turn. And then I start stripping it with flat angle cutters. Put that in there and just get it started. One little snip. And then do the rest with your fingernails. If you have fingernails, you can do that with. All right, it tears pretty easily. Surprisingly easily, actually, and then you just pull it off. One trick on separating the wires is to just create a space on one side of the coax ground cover there, and then just pull out the center part. And then you end up with that, and you can go ahead and twist those together. And then strip that end. Another important thing to note is that you should probably thread these before you fix it in place with a zip tie. Once you get the coax threaded into the driven elements, then go ahead and cinch it in place with a little zip tie. All right, we've finished now putting on the connector, soldering the tip, and soldering and connecting the wires. So all we need now to do is put it on the boom. Now the center element, the driven element, goes on easily. So we're going to have to fasten it with this set screw to keep it from sliding around while we make our measurements and put the other two elements on. So just go ahead and temporarily put that on there. Tighten it in place. It's not going anywhere. And let's put our two elements on. The director goes in front, reflector goes in the back. Let's see if it still balances. Yeah, we can adjust it a little bit. There we go. Now, even though the wire was loose, once you put it on here, it tightens. So that's not going anywhere. All right, now we've got the second element in place, and it was 17.6 centimeters from here to here. Also, we've put the zip ties on there, a little strain relief. And we're about ready to go out and hunt some fox. All right, the fox hunt is on. Up, it's over there, not over there. I think it just stopped broadcasting. Let's give it a second. There we go. Strong signal. Vertically polarized. And there we have it. Well, I hope you have fun at your next fox hunt with this or any other antenna that works. And since there are many ways to put together a Yagi, here's a summary of the dimensions and a list of what I used, but feel free to ignore the entire previous video and build it the way you like to. Take care, everybody. From the Palomino Antenna Workshop, this is Sandy, KB3EOF 73s.